Hello everyone, this is Mahiraja and I am pursuing third year of mechanical engineering at Coimbatore Institute of Technology. I am here to discuss a topic on laser beam technology. Without any delay, let's get into the topic. Laser beam machining. Machining. First, let us discuss about machining. What is machining? Machining is nothing but conversion of a raw material into final product with desirable shape and size through removal of materials. Laser beam machining is asset process. The removal of material is done by laser beams. It is both applicable for metallic and non-metallic components. In this process, a laser beam of high energy is made to strike on the surface of the workpiece. Then the thermal energy of the laser gets transferred into the surface of the workpiece, so that the heat is produced in the workpiece. Due to the effect of heat, the required surface of the workpiece gets melt and then vaporizes. Laser is nothing but light amplification by stimulated emission of radiation. Next, the working principle is nothing but the high energy laser when inserted on the surface of the workpiece, the thermal energy on that laser get transferred into the surface of the workpiece, so that the heat energy is absorbed by the surface, so that due to the effect of heat energy, it melts and then vaporizes the material. Such way the machining has been done in this laser beam technology. Let us get into the types of lasers used. Here we broadly used two types of lasers. One is gas lasers and then solid state lasers. Gas lasers, it is nothing but usage of helium, neon, argon, carbon dioxide, etc. gases is used to produce the laser beams, so that such producer laser beams are called as gas lasers. Next, we get into solid state lasers. Solid state lasers is nothing but the medium such as the ruby crystal, then yttrium aluminum garnet, neodynamic yttrium aluminum garnet, etc. Are used as a medium, and they are doped with a rare element such as xenon, etc. Such the laser beams are produced. As such produced laser beams are known as solid state lasers. The example for solid state lasers are ruby crystal, yttrium aluminum garnet, and then neodymium doped yttrium aluminum garnet. Let us briefly discuss on the parts of the laser beam technology. First, let us go into the pumping medium or the vacuum chamber. In pumping medium, it is a medium which is required to contain large number of atoms. So, due to the effect of atoms, a laser beam can be produced. Next, the flash lamps or flash tubes. Flash lamps is nothing but the flash lamps are nothing but the ruby crystal. The flash lamp means ruby, which provides the necessary energy. The necessary energy is required to atoms, so that the atoms is converted into laser beams. Next, the power supply. The high voltage power supply is required to generate high energy electron beams. Next, capacitors. The capacitors is used to produce pulse mode voltage. Reflecting mirrors. There are two reflecting mirrors used in this process. First one is fully reflected or 100% reflecting mirrors. Second one is partially reflected mirror. Fully reflected mirror is kept on one part, and then partially reflected mirror is kept on the another part. So through the partially reflected mirrors, the energy beams, that is the laser light, passes through the concave lens. Sorry. Next, get into the working. The very high energy electron beams are produced in these laser machines. The high energy laser beams are made to focus on the workpiece with the help of the lens. In this process, the laser beam is monochromatic light. Monochromatic light is nothing but a single color or unique colored light, which means the protons are excited through the atom. The excited proton of the atom is known as monochromatic light, which is such monochromatic light is made to focus on the workpiece with the help of lens, and then extremely high energy density is made to focus on the surface of the material, which has to be removed. The laser crystal, that is the ruby crystal, is in the form of cylindrical shape. The ruby crystal is the two sides of the ruby crystal is merged with the reflecting mirrors. That is 100% reflecting mirror and a partially reflecting mirror. Then the coil, that is the coil means the flash lamp is given a voltage of 1000 watt is given. The flash is stimulated with the help of white lights which is generated from the xenon. The crystal is made to excite and then the laser beam is emitted from the partially reflecting mirror and then made to focus on the surface of the workpiece with the help of lens. The beam produced is extremely narrow and made to pinpoint on a particular area which has a power density of 1000 kilowatt per centimeter square, which produces high heat and then melts the surface and then vaporizes the surface. Thus the required operation is carried out. Let's get into the applications of the laser beam technology. The main and foremost application of laser beam technology is it is not only for metals and not only for conducting elements, it is also for non-conducting and non-metallic components and also for the refractive materials. It is also used in the micro drilling processes and etc. It is also used in the study of spectrums also. In medical field, it is used in the photography sector. Laser beam technology is used in many of the fields. For example, in medical field, it is used for surgeries, hair removals, and then for cosmetics surgeries, etc., etc. In electronic industry, it is used for merging two wires and then wire stripping, etc. In manufacturing industry, it is used for drilling, engraving, etc. Engraving means nothing but making a curve or a cut over the hard surfaces. Get on to the advantages. Tiny materials can be removed with the help of laser beam technology. It also includes non-materials also. There is no tool wear required for this process and also there is no physical contact between the tool, machining tool and the machined product, machined outcome. There is no physical contact. It is happened only through lasers. There is no physical contact or somewhat holding type, nothing is required for it. There is no mechanical work carried out here, etc. The heat affected zone is very low since the laser is made to focus only on a particular surface at particular point only. It is not over the surface and not over the complete material. It is made to focus on a small point. It has it can be easily drilled. It can be able to drill extremely small holes also. The surface of the materials like rubber, plastic and also can be machined here. Let us get on to the disadvantages of it. The main disadvantage of it is the efficiency of the laser beam machining is very low and its cost is very high. The flash lamp of the laser beam machine is the lifetime of the flash lamp of laser beam machining is very low. It is limited for thin sheets. It is allowed for the moderate and the thick sheets only. It is not applicable or advisable for thin sheets. It is not able to drill a deep hole, etc. or the disadvantages. There are not only advantages. Finally, I am concluding the topic that there are not only advantages but also have disadvantages. In comparing to disadvantages, the laser beam technology has more and more advantages, such as it is applicable for non-materials, it is applicable for non-conducting materials, it is applicable for soft products such as rubber, glasses, etc., etc. Let to share a working animation graphics of laser beam technology. Let's get into the video.
Machining is a non-conventional machining process.
Laser beam machining. And laser beam machining is a non-conventional machining process in which material is removed from the workpiece surface using heat. Laser stands for light amplification by stimulated emission of radiation. A laser is produced when the electrons in atoms of special crystals are energized using electric current. Generally, garnet crystals are most commonly used in solid-state lasers. Yttrium, aluminium garnets, and doped with neodymium, which is also called NdYAG, are most popularly used. These excited electrons emit photons. Photons are the particles of light, and these emitted photons form a concentrated beam of light, forming a laser. Laser beam machining is best suited for machining brittle materials with low conductivity, but can be used on almost every material. To understand the laser beam machining process, watch this video till the end. This video will cover the following parameter effect, advantages and disadvantages. Beam strikes the surface of the workpiece. The heat energy from the laser beam is transferred to the workpiece. This heat energy absorbed, melts and vaporizes the material from the workpiece surface. Construction. The laser beam machine consists of following parts. Power supply. It requires the power supply of 1 to 10 kilowatt. A high voltage power source is used to produce light in flashlight tubes. Flash lamp. Flash lamp or flash tube is used to charge the electrons of the atoms in the crystal, which is also called as pumping medium. Capacitor. Capacitor is used for operating the laser beam machine in pulses. Pumping medium. Pumping medium in this case is a ruby crystal, which has a large number of atoms, which when absorbs the energy, their electrons produce photons. Working. When the switch is turned on, a high voltage power supply is applied across the flashlight or flash tube surrounding the pumping medium, in our case it's ruby crystal. As the light is powered on, it emits high energy photons. These photons are absorbed by the ruby crystal. This absorbed energy causes most of the electrons contained in the atoms of the ruby crystals to be excited at a high energy level from its ground state. After a short duration, as the electrons from high energy level comes to ground state, they emit photons. This emitted photon stimulates the excited electrons to return to their ground state, thus producing more photons as they return to their ground state. Thus a pair of photons are obtained by utilizing one photon. Thus, we call this process as amplification of light using stimulated radiation. As the photon's concentration increases, the laser is formed. A 100% reflective mirror is used to reflect all the photons back to the crystal, whereas a semi-reflective mirror reflects some of the photons back, and escaping photons through a semi-reflective mirror forms a high-energy laser beam. Then a lens is used to focus the laser beam onto the workpiece to be machined. Interaction of laser and workpiece produce a large amount of heat, thus vaporizing the surface of the workpiece, thus cutting grooves of various shapes, or cutting the workpiece. Application of laser beam machining process. Cutting, aerospace, steel, electrical, and medical industries for machining. 2. Machined in the workpiece, where different sizes can be machined, as the laser can be moved. Disadvantages of laser beam machining. Of the lamp is short. Hope you have understood laser beam machining process. If you are new to ADTW.
And finally guys, with the help of that video, you can get a better idea on laser beam machining and laser beam technology, the working principle, then advantages, disadvantages, the applications, the parts used, etc. etc. Laser beam machining is highly recommended and a highly beneficial process among the machining processes. Hope you got a better idea on it, and thanks a lot for giving me this opportunity. Thanks a lot for your patience. Thank you.